Welcome to the ESP32 Sensor Ball Project. This is a beginner project exploring the use of a XIAO ESP32C3 microcontroller board and my first time using ESP32. The goal of this project was to create something to interface with some sensors and a button to learn more about the capabilities of the ESP32 platform. Included in this project is a light sensor using I2C, an accelerometer, gyroscope, and temperature sensor using SPI, and a button. This sensor ball is a great way to explore many of the ESP32 features. This is due to the multiple communication protocols used to interface with the sensors, interrupts for monitoring button presses, and web hosting to view sensor data. All files for recreating this project will be shared below with a PDF guide sharing the learnings I've made so far. Note that I'm still in progress on this project, so I will update the documentation as I have it and create more videos on the project as I go along. I'd love for someone to recreate this project to see what they come up with. Now we will walk through the hardware design for this project. The two PCBs designed for this project are the top and bottom boards of the hardware stack. These are the sensor board and the battery board. We'll start with the sensor board. The sensor board has a light sensor which communicates with the ESP32 board via I2C. The chosen sensor produces a digital value that can be converted to light units of lux. The light sensor is the Nuopto XYC ALS21C K1. This sensor was chosen due to its availability for assembly through JLC PCB, since it was critical these boards were ordered assembled, since I have limited soldering equipment and ability. There is also an ST LSM6DS3TR-C accelerometer, gyroscope, and temperature sensor. This sensor communicates with ESP32 using SPI. The sensor returns 16-bit values in 2's complement. My firmware driver is still in progress for this sensor due to issues with sensor setup, but I'm making good headway now that I have located an associated application note. Also, a button was included for user input. This was added to the board to be able to experiment with the ESP32's interrupts as well as to add some fun fidgetability to the project. Lastly, there is an indicator LED on the sensor board for indicating when power is present. Picking the resistor value for this LED was a design mistake on my part, since I assumed 50% brightness wouldn't be too bright based on the datasheet. However, without the 3D printed enclosure, it's like looking at the sun. That covers the sensor board hardware. The other piece of hardware designed for this project is the battery board. The battery board's main purpose is to allow a battery to be easily plugged in to power the project. Without this board, a battery would have to be soldered directly to the ESP32 board. This would mean that the battery terminals would have to be desoldered to change out the battery and would make it much more inconvenient to do so. There is also a resistor divider on the battery board for monitoring battery voltage. This was suggested on the Seed Studio ESP32 Getting Started page and seemed like a good idea. Also, this allows for the use of one of the analog pins in the firmware of the project, which uses another feature of the ESP32. The final piece of the battery board is the pogo pins. You'll have to imagine these are pogo pins instead of 2.54mm headers. Pogo pins were chosen since they make contact and apply the battery voltage to the XIAO ESP32 board. However, this could easily have just been two wires soldered to the ESP32 board and would have achieved the same thing since the board stack is soldered together anyway to keep a low profile. That's not something I considered until final assembly of the product. This wraps up the hardware side of this project. Note, the largest driving factor in component selection was the availability of parts in the JLC PCB assembly component library, as well as anything that was easy for me to hand solder. Following this constraint, the only components that I hand soldered were the battery connector, through-hole resistors, and the button. Now we'll move on to the physical assembly of the project. The assembly process for this project is fairly straightforward. Here you can see all the parts laid out in front of us. On the left is the sensor board, in the middle is the ESP32, and on the right is the battery board. First, we'll start by placing long header pins through the ESP32. This will provide the structure for the board stack. Then, we'll pick up the sensor board and insert the button. We'll sandwich this on top of the ESP32 board. Then the battery board gets the JST connector, and a pogo pin and a resistor. Then this gets sandwiched on the bottom, and the pogo pin makes contact with the ESP32. Then by magic, we have the fully soldered version, just like a chef prepared with the little clicks for bonus. Then we put it into the enclosure and quickly coil the antenna around the inside of the enclosure. The project is complete when the top gets placed on the enclosure. Here I'm showing an older version with it all just screwed in together, and that's the final product. The final piece of the project I'm still working on is the firmware. I have several ideas for what I want the end result of the firmware to be, but I have yet to finish, mainly due to some issues with getting the accelerometer to run before I found the application note. The benefit of the previously described hardware is that it provides a great playground to explore many of the ESP32's functionalities as previously described. I'll create another video showing when I'm done with the firmware. For now, I just want to share a video showing off the hardware and the end result of the project so far without proper firmware. You can see the screenshots here showing what my firmware looks like, which is just a simple web server with details shown on the screen. I've put all the files and information required to create this project in the description, and I've also created a PDF guide with code and details on each piece of the firmware as I've worked on it so far. Hopefully someone else will be interested in completing this project themselves, and I look forward to seeing someone else's end result of this project. Overall, this was a great introductory project using the ESP32 C3 board, and I look forward to working on many more projects like this one. Please like and subscribe to see more of my projects as I continue to learn and share. Thanks for watching.